Hi, thanks for tuning in to the Oscar XO2 installation video. My name is Jake Lau. I work with LOWRIDGE ONSITE Technologies, and I'll be your tour guide through this process. Before diving in, just a little brief explanation of what the Oscar XO2 is. The Oscar portion is what's pictured right here. It's just drip tubing in these coil formats. We call these Oscar coils on a shallow sand bed with a supply and flush line reflected by these 1-inch lines on either side of the coils. And that's the dispersal component. There is treatment going on as water goes through this sand here, but its primary function in the Oscar XO2 is the dispersal part of it. So that's the Oscar. The XO2 refers to the pre-treatment before the wastewater goes out to the Oscar system to be removed, and that's an aerated ATU system. And so we'll get into what those components are, but it's one system, the Oscar XO2, with two components to it, the Oscar drain field and the XO2 aeration. So diving right in to the installation steps, we're going to go through kind of in these categories, the plumbing that's required, the headworks that we have, there's a couple of connections there, and we'll walk through how to diagnose and make sure everything's working correctly once installation's complete. The aerator, so what's going on in this picture right here, you can see the water bubbling, and there's a line coming from the aerator in here that's going into the diffusers that's aerating that water in there. So we'll go through that, and then the drain field. As we talk about the drain field, there's going to be some specific steps, and we'll have plenty of videos and pictures to show with this, but a basic outline of the drain field installation steps is initially from your design, whether it's engineered or you've worked with your health district that's local to you, whatever you have, the designated area for the drain field for the Oscar portion of this system, we're going to call that the basal area. And so what we like to say as a first step is to stake out that basal area. 9 times out of 10, that's just going to be a rectangle. From there, that area, we're going to prep that ground. And so as you can see pictured here, they've just used the teeth in the bucket of the machine here to comb through here. And that's what we're doing. We're opening up the pockets. We're opening up the ground to allow that wastewater to infiltrate easier. You can see here these clumps of sod that have come up. The goal here is not to remove anything from the ground that's here. In fact, more often than not, these systems are going to be going on sites where there's limited ground. So the last thing we want to do is remove anything. So if sod or anything comes up, then it comes up, and whatever stays. That's fine. We don't mind this native sod here already and staying there in bigger clumps. So that's, again, the goal is not to remove anything. Whatever comes up, and whatever doesn't. That's fine, but we just want to comb through this basal area. Once that ground has been prepped, then it's a matter of applying sand from the side. You don't want to be driving your machines on the prepped ground until there's sand on top of it. So we'll apply the sand to that, and once the sand is there, then you will attach those Oscar coils from that very first slide and hook those up the way that each site will need it to, and that'll be site specific, and we'll get into that. But those are the installation steps for the Oscar portion for that drain field. All right, so let's start talking about tanks now. At the point of this recording, this is a very new system, so many of the tanks and a lot of the components here are going to be based on drawings that we have and not photos of things actually in the ground. But for our purposes, I think it's still providing plenty of clarity for what we're talking about for this initial installation instruction. So with exception of specific regulations in certain counties in the state that you might be in, and certainly bigger sites, whether it's commercial sites or just larger residences, the vast majority of the residential sites that you'll be installing are only going to require 2,000-gallon tanks. Both of them are going to be double compartment. And right now in the pictures are showing concrete tanks. Poly tanks are perfectly fine. Plastic tanks are perfectly fine. Just making sure that in both instances we're doing our due diligence on bedding them correctly. Settling is no good for any septic system, and this system is no exception to that. But for pictures, it's a little easier to look at this when they're drawn as concrete tanks. But plastic is perfectly fine. To conceptually wrap our heads around what we're going to talk about, this first tank is everything to do with the XO2, with the aeration. This second tank in the system has everything to do with the Oscar, it going out to the drain field. So if we can think of it that way, that might help as we're walking through things. The installation part, the aerator. So we're going to start with this first tank. The aerator here, this down here is a bird's eye view of this same tank. And we have the aerator drawn right here on top of the tank. That is not a requirement, the aerator being right there. We drew it here for purposes of being able to talk about it and being able to see it, but it may be more feasible for it to be below an eave or closer to the control panel where that is. But the point is the aerator is going into this first tank. It's all paired, and we provide adapters so that it's all 1-inch pipe here. This configuration down below here where I'm circling, where the diffusers will go, we're providing the diffusers, and we're providing a lot of this pre-manufactured along with a union up here in the riser to be able to pull that out conveniently and service the diffusers. So that's the aerator, and that's that initial first tank. The second tank, for everything going to the Oscar, we have here a headworks drawn on top of the tank here. In this instance, this headworks, what we call our reverse flush headworks, this is required to be on top of the tank for a number of reasons, whether it's thermal protection or ease of the pump lines and where it's going to, and we'll get into the specific connections that are going in and out of the headworks at a later point, but that's the location of the headworks, directly on top of that second tank. The plumbing of the vent line, and this is a bit of a nuanced thing. On the other side of this headworks, again, we'll get into it, there's 3 connections that you'll be making, 2 of which are the supply and flush lines going out to the Oscar. There's one right in the middle, and on the headworks box itself, it has a label that says tank. And that's our vent line that we want going right across these tanks and in right here. And we'll talk about that a little later in the specifics of that. But we'll want to make sure that vent line is plumbed back to the beginning of the system, right here in the inlet of this first tank. And that'll do it for this slide. So just as the previous slide was showing, we had this top configuration here, these 2 tanks end to end with that. As we all know, different sites demand different ways to connect things. So this side by side is perfectly fine. What you'll want to have, as you can see, you want water flowing the same way it would flow here. So you want this last third of this first tank where the aeration is happening to be connected with this crude red line here into the 2/3 section of the second tank. And then that last third is where the pump will be going out to your headworks. And you can see here also denoted by these asterisks here that vent line we were talking about would be making that connection over here. It's always going to be pressurized, so no need to use 45s and worry about friction loss. Just use elbows, keep it straight, keep it clean, but that's where that will be going. But either of these tank arrangements are perfectly fine. That's what we're looking at there. So again, repetition is key. This vent line that's going across these 2 tanks is going into this 4-inch T that's going to be spliced on the outside of the tank on the inlet going into this initial tank. This 4-inch sewer T that's pared down to 1-inch PVC up here is pre-made and comes with the kit. So you don't need to make this, but this is where this goes, right at the beginning of the system. We want that water that's being flushed in our different flush sequences to come back through this vent line back to the beginning of the system. That's an important part of all of this. So that's where that goes. One last thing about the tanks, and this will be one of the reasons why specific tanks for this system will need to be found, whether it's with a precaster or discussed with your distributor that's giving you or selling you the plastic tanks. In this first tank where the aeration is, we want this flow-through hole to be about 2 feet off the bottom of the tank. Now, if the hole is higher and you're using baffles to get down to about this 24-inch mark, that's perfectly fine. But this 24 inches off the bottom of the tank, that's where we want that water being collected as it dumps over into the second tank. In this second tank, the same hole that we only want about a foot to a foot and a half from the bottom of the tank, and so that's specific. Same kind of situation, but those are non-negotiable. That's important for the system. So specifically talking about that reverse flush headworks. So on this second tank, the one that's going out to the Oscar drain field, again, we want this headworks directly on top of the tank. A little bit of the kind of guts inside of the tank. We have here, again, provided in the same kit, a half-horse turbine pump, and that's going to be the same pump for all these residential systems, and it's going to have an adapter to pair down where it's being connected down to 1-inch PVC. The goal was to have everything so that you can use just 1-inch PVC. So you just need that one size size of pipe, and it's a pretty typical size of pipe, and that's going to go directly into the headworks out of the riser here. We'll also provide a 1-inch union so that in need of servicing the pump at a later date, you're able to just disconnect the union and pull that out. But that's where that is. We'll provide the floats. The float placement is pretty simple. We'll have the floats already pre-tethered on brackets that you'll just attach to a 1-inch line of PVC that can be attached to the riser here to hold in place. But it's a 2-float system. The bottom float, we just want drilled at the same elevation as the top of the pump. The idea being that with the float being there, the pump is always going to be submerged in water. That's the goal. The top float here, we just want a minimum of 4 inches, but I'd say anywhere between 4 to 8 inches above that, and that's your working volume. And this top float is just your high water level alarm float. But those are those floats there. And again, this pump line coming out, we just want straight pipe, unless specifically noted in your design or engineering, no check valves needed, just straight pipe elbowing over with a union there, and then elbowing again. So just 2 elbows, everything's pressurized, so just elbows, make it nice and neat, and that's what we're looking for there with the internals of this second pump tank going into the headworks there directly on top of that second tank. So here are some of these parts that I was talking about that are included. This isn't all of them, but this is some. We're using 80-liter high-blow pump along with the diffusers. We're providing those. The diffusers will actually already have Teflon tape on them, and so those will just be screwed in to the configuration for the diffusers in that first tank. Again, here are the floats there, already pre-tethered. No need to adjust the tether that we have on those. That's how we want them. And those are those brackets, and that will just slide on to a 1-inch PVC and be able to be drilled in. The screws are already pre-drilled right in there. And the unions, here's an adapter for the top of that pump to pair it down from that 1.25 inch threaded to that 1-inch, so all you're having to use is that 1-inch PVC. Here's just an orifice shield with a screw in it. Depending on the kind of tanks and the style of the opening, this may or may not be feasible, but regardless, we supply it. But if you have a plastic riser, this will drill right into the plastic riser, and a 1-inch PVC will snap into that curve right there, and that can hold in place the float tree that you have for your 2 floats. And last but not least, this is the 4-inch sewer tee paired down to that 1-inch PVC, and that's where that vent line is going to go back from the reverse flush headworks to the inlet of the first tank. So that's that. Like I said, there are more parts included, but these are the ones that we've been talking about that we'll have there in that kit. This picture, just briefly, particularly with the reverse flush headworks that we want on top of the tank. We realize that the tank, to be able to service this headworks, we want to make sure that the lid is going to be at grade. The boxes themselves that they come in are 12 inches high or a foot high. And so if the tanks are going to be deeper in the ground from where grade is going to end up, we do provide specific, what we'll call riser lids, for our headworks. Essentially, it's just an extension. Here, it's basically another box in this top box has the bottom cut out of it, so when you pop the lid, you can just reach down deeper to where the headworks is. But this can be adjusted so that if you don't need a whole foot, you just need another 6 inches. This can all be adjusted, but point being, we do provide riser extensions, or an extension for our headworks box, to make sure that it is able to stay on top of the tank, directly on top of the tank, but also still at grade if that grade is going to be more than a foot above where that tank is. And the final piece of this before we go on to the Oscar installation is the connection of the aerator. So a couple of things about the aerator, just the placement of it. The bottom of the box that the aerator comes in needs to be at least the elevation of the top of where the riser will end up. So you can see here the riser box is in blue with the aerator inside. And so, the aerator box is in blue with the aerator inside, and you can see the bottom of that box is at the same elevation as the top of the riser. And from there is where you'll have your connections to your airline where the diffusers are, and that's from the bottom of that box is also where you will have your connections coming from the control panel to give power to that aerator. Again, as mentioned, the aerator comes in a LOWRIDGE provided box. The box does have, not exactly like this picture shows, but it does have venting designed in the box with a couple holes drilled in the lid, and so air is able to flow through there, and specifically able to be sucked from the air in there, and that's where the aerator is getting the air that is blowing into the diffusers. So that's all in place. And then we'll walk through briefly how to install the diffusers. Most of the pieces are provided by LOWRIDGE. So moving forward, you can see here that from left to right, this first box furthest to the left is how the box will show up when it arrives at your site. This is the assembly package of the aerator. The aerator will be held in place by this large zip tie here. We've got a handful of pre-manufactured fittings, PVC fittings, along with a union. And so we'll focus on these pieces right here. So you'll see this will all be one piece. You'll have these threaded pieces on either side where you can twist in your diffusers that'll also be provided by us on either side. And then you will simply connect and extend. So if you can see this will be turned around, and so it's on this side. This next slide will help clarify some of this as well. So once you tie in or thread in your diffusers, what you're looking at here, so again, going from left to right, from top to bottom, left to right, here you'll notice that so this wall where my cursor is circling, that's the partition, that's the wall in between separating the two compartments of the tank. You'll see that the pre-manufactured piece has this cap below here to keep the diffusers off the bottom of the tank, but it's also keeping the diffusers a little bit separated from the tank as well. So you can see just below here, this area is going to be resting on the bottom of the tank, forcing the diffusers to be above the bottom so it's not just blowing into sludge. And then it's also extended out so these diffusers aren't right up against the wall here in the tank. And then what you're going to do is you're going to kind of hand measure, because you want your diffusers will be right up against this partition of the tank, but then you'll want to have it extended out so that when you connect your airline, you'll be able to reach in there through the riser lid. So you'll eyeball how much pipe you need, and you'll attach that to the end of this T and connect it to that other pre-manufactured piece. So if that makes sense. So that way, these two pieces are what's going to keep this diffuser from the bottom of the tank. This will extend out as far as you need so that you can get access to it when you need to service it. And then from there, when that's sitting on the tank, then you're just adding your long stick of pipe that's essentially going to serve as your airline. And that's the setup that you'll have for your diffusers. So when all's said and done, those diffusers will be sitting on the bottom of the tank. You'll simply elbow over, use a union, a 1-inch union that we'll provide. Everything is going to be 1 inch, by the way, and that's going to go directly out of your riser, and then you're going to be good to go in terms of the installation of the diffusers themselves. Then, just as a last note for the connections, the airline, this picture to the left, that's going to be, and this hole is drilled, and this opening for this 1-inch piece, 1-inch pipe goes directly into that. That's already drilled and provided, so it's just a matter of having that airline that's coming out of your riser connecting into that bottom of that tank. And then to the right here, where the finger is pointing, that's where the conduit will go that has your wires from the control panel providing power to your aerator. So that's how that all works. And so with that, we're going into the specifics of the Oscar, the sand bed, the coils, all the good stuff, the eye-catching purple drip tubing. So here we go with that. In this slide, we've got 4 different videos that I'll just start one at a time as we talk through. But this, we talked about that prepping of the ground. Again, that's what you're looking at. You'll see plenty of clumps of sod that are left or have been moved around. That's fine. Leave them as they are. But we just want to comb through that designated basal area. And that's what we're looking at there. After that, once you've done that, we're going to apply this sand. And so you'll see shortly a truck back up. And from the side, it's dumping sand onto the prep soil. So you don't want that truck kept going and went over the prep ground. That's not what we want. The point of this is to open up pockets, and driving over the prep ground will compact and make it difficult for water to infiltrate there when everything's said and done. So important that you'll do just as in this video here, that you'll want to dump that sand from the side without having to drive on your prepped ground. But once sand is on there, then feel free to maneuver and walk around the sand that's on top of the soil, if that makes sense. So you'll see here they've got their mini on top of the sand as they're moving around and making that all work well. A point that we haven't discussed yet, the coils themselves. The coils are all going to be in a straight line, so all connected to each other. They need to be level. The rest of the basal area does not need to be level. They have a minimum amount of sand that's needed. Again, and so refer to your designs, refer to your engineering, and your county-specific requirements. But the only place that's required to be absolutely level is the area where coils are specifically in this. And so you'll see here the last thing we'll do is attach these coils. You'll see here, as he's making these connections, he's got the coil, and he's got this brown tech line, which is something that LOWRIDGE provides, and he's making the connection here. If you can see right below his hands, he's making that connection into a little elbow at the end of this line here that has a barb fitting that will attach drip tubing together. Those fittings are all provided by us as well, and so it's just a matter of cutting those fittings into the pipe where it makes sense. Now, you'll see, as I run this again, when we get to the end of this, you'll see that some of the coils are connected together before they have connections to the supply and flush line on either end. That's going to be site-specific. So again, refer to your designs, to your engineering for the specific site, because that's going to be site-specific. But ultimately, what we're going to look at here, as we pan down here, so you can see here you've got these 2 coils connected to each other, and these, so each in this line of coils here, every 2 coils have a connection to each other before you have a connection to your supply and flush line. I guess another thing to note here before we leave this slide, whether this side to the right is your supply line and this side is your flush, or vice versa, it makes no difference provided that you connect the coils correctly per the design. So if this is your supply line to the left, let's say, and all your coils still have, so in this case, you have 2 coils, they're connected together in one end, and then on either end you have a connection to the left and to the right. So long as that's consistent, whether water is coming from the right or to the left, water will still get to all these coils and still be able to flush. So whatever side this is on is irrelevant so long as you attach these coils correctly, and that'll be site-specific. This is so important that I dedicated its own slide and gave all caps for the word must. Oscars must be installed on contour. If you have any questions or confusion, or you are less than 101% sure of what I mean when I say Oscars must be installed on Contour, give a call. The numbers will be provided at the end of this. Shoot an email. Ask a friend. Oscars must be installed on Contour. And so this next slide has a bit of a video. And so before I start playing, you can see here lengthwise, the long end of this Oscar drain field will go from here down as my cursor is going. So that's the long end. What we want, you can already see from here down to here that the soil, that the sand is getting deeper and deeper and higher. That is because this is not on Contour. If this is on Contour, then even if there is a slope, that the up gradient side, so the higher side of where the Oscar is going to be, the up gradient side of the length will all be at the same elevation. This isn't. So let me start playing this to make it clear. So you see just getting deeper. And so you may look at this and think, oh, that's not that much. It's maybe a difference of, anywhere between 6 and 12 inches. It is a difference. Keep in mind that Oscars and Oscar XO2 are being installed more often than not in soils that either don't have a lot of soil, or the soil is, or that the soil is marginal. So water, even though you have your coils level, gravity doesn't stop being in effect. Water will still go where gravity pulls it. And so if you have marginal soil and this isn't installed on Contour, then what you'll have is water end up coming to this bottom corner right over there and potentially ponding there. That's not okay, and that doesn't happen when these are installed on Contour. So again, if you have any questions about that, reach out. But you've heard it here multiple times. 2 devoted slides to this. Oscars must be on Contour. In fact, let me show it to you again one more time. Oscars must be installed on Contour. So just to clarify some of the things that I have talked about the Oscars, here's a good example. This drawing is to reflect a sloping site, and one of the reasons I know that is because if this were a drawing for a flat site, then these coils would just be smack dab in the middle of this staked out basal area. But when there is a sloping site, and the slope is going from up here down towards where it says Oscar here, so the slope is up here, down here, what we want is to make sure that we're taking advantage of this whole basal area, and so we'll have the coils right up against the edge of the top side, so that way when the water comes out of the drip tubing and it is streaming down, it's utilizing all of this sand and all of the rest of this area, if that makes sense. But you'll also notice that when talking about Contour, if the slope is here, we only want the slope coming from up here down here. We don't want it from up here down diagonal wise. That's when you end up having water collecting in one corner, potentially ponding and that sort of thing. So we want the coils all in one line, but if to be on Contour, this needs to be slightly curved. That's fine. That's completely doable, but on Contour, that's non-negotiable. One last thing that may be easier to see in the drawing as compared to the video that we were showing. You can see here you have these coils. You have a connection from this line. Let's just go ahead and call this the supply line. Like I said, it doesn't matter so long as you hook up the coils correctly, but let's say you have the supply line here, so you have a connection from the supply line to this first coil. The other end of this coil is hooked up to the coil next to it, and the end of this coil is hooked up to your flush line. So you have 2 coils paired together, and these 2 coils together have one connection to the supply and one connection to the flush. So long as you do that, it doesn't matter if this is the supply and this is the flush or vice versa. But that connection, and this connection with the 2 coils together, I know that's what we've seen in the video and in this drawing, but it'll be different depending on the site. For example, if you only had 5 coils total in your whole drain field, each coil would have its own connection to the supply and flush. It wouldn't be connected to the coil next to it. So just need to keep that in mind and look out for that. But that's just a better illustration of all of that. Now I want to get into some frost prevention tips. If you're in an area where freezing is a considerable issue that you might be looking at, we have a couple of just rudimentary, perhaps primitive tips on on doing that. You can see in this picture here where I have my cursor going, you can see this supply line going out to the coils. It's dug down a bit, and it's not just a matter of it being dug down, but that there's a drop in an angle to allow water to drain out. The whole thought behind preventing freezing is that if the water isn't there, it can't freeze. And so we want to be able to give the water a place to go, ideally back into the tank. So this drawing may help. Again, so you can see these red lines here. If you think of that as kind of a side view, these red lines are the coils, and they're all going to be level. But you see this black line, and perhaps it's a bit exaggerated for our purposes, but to give the idea, here's the angle that we're talking about to allow that water, once it's been pumped out, you're going to have water coming out of the emitters, even in between doses, but we want this water to drain back to the headworks, back to the tank. There are no check valves in this unless specifically designed or engineered, and so all the water, if we allow the drop and this angle for water to drain back, we'll be able to go all the way back into the tank. So that's what we're looking at. And so, as with anything, when we're looking for water to be able to drain back, bellies and lines, having low spots where it can sit, again, that's the whole idea. We don't want water sitting anywhere, and so it having drop places, as we can see in this angle, that's what we're looking for. So just a nice tip for us there. All right, last kind of bit that we have for this training video, the startup procedures. This is the holy grail for diagnostics for Oscar systems, whether it's an Oscar 2 and Oscar XO2, which this is for. This headworks is all going to be the same, and the diagnosis, what we call the startup procedures, are going to help us make sure everything has been wired correctly right after initial installation, and if for any reason you have to go back out to look at something, if there is an issue, because we have expected pressures on these pressure gauges and expected flows going out to the Oscar, when something is off, this will help us pinpoint where the issue might be. So these startup procedures need to be done at the conclusion of every installation. If you don't do this and you have problems, this is the first thing you should do, these next few steps that we're talking about with the startup procedures. So you can see here, there's 4 connections that you'll make. This is the inside of that reverse flush headworks. That headworks that's on top of the tank that has the pump going out to the Oscar, going out to the drain field. And so the inside, everything on the inside here is already made for you. This is how it will show up on site. The connections you'll make is on the other side of this flow meter. This is your supply line going out to your Oscar drain field. Here is the flush line coming back from your Oscar drain field. So these 2 lines on either side over here are the ones going out to the Oscar. This one in the middle, on a lower elevation than these other 2, this is that vent line going all the way back to the beginning of the system. And in here is the line coming straight from the pump through the riser and then into the headworks. So it's those 4, from the pump, out to the Oscar, from the Oscar, and the vent line going back. So another way we can look at it, just to bring back an old picture, we'll go ahead and look at this real fast. Bear with me. Here we go. So here, you can see here these 2 connections on the corners here. So the flow meter, this is the supply and flush. These 2 lines are the ones going out to the Oscar. There's one in the middle. That's the vent line going all the way back to the beginning of the system in that 4-inch T paired down to that 1-inch PVC. And this line over here is from the pump. So that's what we're looking at there. And again, just to note again, every reverse flush headworks is going to have 3 pressure gauges, always have the same labels, 1, 2, and 3. They're going to have 5 solenoid valves and a water meter. So this headworks, this reverse flush headworks, is facilitating 3 things that the water is going to be doing. The main thing is water going out to the Oscar drain field. So the pump comes on, goes through the headworks, out to the Oscar coils, and there it stays. When that happens, what's going on in the headworks is that valves 1 and 2, or the valves labeled S1 and S2 if you're looking in the headworks, those valves are opening. All the other valves, the remaining 3 valves, are closed. They're normally closed valves. And so with just 1 and 2 open, as water's going through the system, you'll immediately see pressures on gauges 1 and gauges 2 register. And when everything settles out, you'll end up having probably close to about 50 psi with a little variability, but about 50 psi on gauges 1 and 2. Gauge 3 will be the last gauge to pressurize, especially if it's the first time you're running water through the system. So you may need to give it a minute or so. But eventually gauge 3 will start collecting pressure, and you'll have a little bigger of a range there, depending on how big the drain field is and how far away it is. That might determine a little bit of variability, but you'll have anywhere between 40 and 50 psi on that third gauge. You should not have any water coming back to the tank, and at that point, once everything pressurizes, we'll take a flow reading, and we'll walk through how to do that. But those pressures and no water coming back into the tank, that's the dose to the Oscar. So again, that's just valves 1 and 2 opened up. These are the expected pressures on those 3 gauges, and no water coming back into the tank. When you have those, at that point, take a flow reading. And so if you remember, here's a close-up to that flow meter that's in the Headworks box. These flow meters come from Netafim. And for our purposes, we're not necessarily going to look at these larger numbers up top. What we're really going to do is we want the flow rate. We want to capture how fast, how quickly the water is leaving the system. So once everything pressurizes, you see these 3 dials down here at the bottom. This middle one, it's also the largest one. Every notch in this little dial is 1/10 of a gallon. So when this red dial makes a complete rotation, that's a gallon. And so what we want to capture is gallons per minute. So once everything's pressurized, literally time for a minute and count rotations, because every full rotation is a gallon. And so what we're looking for, and this is going to be site specific, it's probably the one time you have to do math for these systems on here. We have 2 different sized coils, and again, this will be specific to your site. We have OS 50s and OS 100s, or a 5-foot coil and a 7-foot coil. Every OS 50 drips or gets rid of water at 0.35 gallons a minute, and every OS 100 gets rid of it twice as fast, at 0.7 gallons a minute. So let's just say we have a drain field of 10 OS 50s. So to find out how much water should be leaving the system, you take the number of OS 50s, or whatever size coil you have. In this case, we'll just say you have 10 OS 50s. So you take this number, 10, of the number of coils you have, and multiply it by this constant, this 0.35 gallons per minute in this case, since we're talking about OS 50s. And so that 10 times that 0.35, that'll give you how much the whole drain field can get rid of. So in this case, 10 times 0.35 gives you 3.5 gallons a minute. So if that's what your drain field is, if that's the size of the drain field that you have, the Oscar field that you have, that you're supplying water to, when you're taking this flow reading, that's the number you should be hitting pretty close to. You should see over the course of a minute, once everything's pressurized, this dial turn about 3.5 times. That's what you're looking for. If it's turning way faster than that, you've got a leak someplace because more water is leaving the system. And if it's going significantly slower than that, you've got a plug someplace. So that's kind of what we're looking for. But that flow reading during that dose with just valves 1 and 2 open, that's what we're looking for. I know this is a lot of information, but this video, you can watch it as many times as you like, and you can always call with questions. But that's what we're looking for. So that's the first step of the startup procedures, and just to show the flow of water going on in that instance. When the water kicks on, when the pump kicks on and the water's coming in, again, unless electricity is coming to these valves, they stay closed. So with valves 1, S1, and S2 open, you can just follow the arrows here. The arrows will allow water to go through this first valve. It can't go past S4, so it's forced to go through this guy right here. This is a disc filter, so it's catching organics that are in the water before it gets out beyond this. Goes through 2, down to this lower part of the plumbing, up and around through the flow meter, and that's the supply line to the Oscar. So that's how that works. That's the dose. All right, the next step in the startup procedures is opening up valves 3 and 4. So before we just opened up 1 and 2. In this instance, we want the pump running with only valves 3 and 4, or S3 and S4, opened up. What this is doing, and again, all of these things that we're testing are things that the system is automatically doing throughout the day, but we want to test them manually after you do the install to make sure, again, that everything is wired correctly, that the pipe and the plumbing has all been done correctly. It's just a way to double check and really make sure that, hey, the system's been installed correctly and it's working. So this is simulating the disk filter flush. So if we go back to the slide just previous to this, you see this disk filter right here. This is collecting and catching organics as the dose is going on, but multiple times a day, it's going to reverse the flow and actually flush out everything that this has been collecting and send it back through that vent line back to the very beginning of the system. And so it does that when we open up valves 3 and 4. And so again, the pressures, we have expected pressures that we should see. Gauge 2, again, they're always going to be labeled 1, 2, and 3. Gauge 2 should have twice the amount of PSI as gauge 1. Typically, that means that gauge 2 is going to have about 20 PSI and then gauge 1 about 10. I've seen a number of things. I've seen gauge 2 have 10 and gauge 1 have 5, or 15 and 7 or 8. So long as that ratio is all right, then there's nothing wrong with the disk filter, and that's what we're looking at. If, say, you have 40 psi on gauge 2 and nothing on gauge 1, then that will probably indicate that the disk filter, which is the thing in between those two gauges, is probably clogged. In that case, you would know it would need cleaning. After initial installation, that might be some glue globs that got in there, or pipe shavings that might be holding some stuff together. Easy enough to clean out, but that's what we're looking for, that ratio of twice as much PSI on gauge 2 as gauge 1. Other things that you should see, you should hear a lot of water coming back into the tank, coming really fast. No pressure should be going on gauge 3 because no water is even going to that part of the headworks, and no water should be going through the flow meter. So those are all indications that you should see when you're doing the disk filter flush. And so flow of water, what that looks like, now we're opening up 3 and 4, and so we're reversing the flow of water through this disk filter, and that reversal of water is allowing everything that this disk filter has been catching to actually blast out and leave. So it's going through 3, up and around, reversing through the disk filter, through 4, and then it goes down from here. This is a side out. It goes down to this lower level of plumbing, out to this vent line, and that's going back to the very beginning of the system. All right, so the third and final step of the startup procedures is testing the last function that this reverse flush headworks does, which is the flush of the coils in the drain field. So the idea is that this headworks is going to allow the system to automatically clean out that disk filter that we were just talking about and the coils out in the drain field. And so the way it does that is to get water out there in the first place, we're going to do what we did initially with that dose, open up valves 1 and 2, and then in addition to that, we're going to open up valve 5. So we're opening up valves 1, 2, and 5, 3 and 4 are going to be closed. When we do that, we should see on gauges 1 and 2 pressure floating around 35 to 42. There's probably going to be about 3 psi-ish disparity between the two gauges, but relatively the same in that range. Gauge 3 should be right at 0 psi. It might be bouncing on the post a little bit and registering, between 0 and 2 psi, but it should be just about zeroed out. Water's flowing past that gauge, but it's flowing freely now that we've opened up that 5th valve, and so you shouldn't have any pressure backing up on that gauge. So again, other indications that this is going correctly, you should have a good flow coming back into the tank. And you'll have a pretty fast flow going through that flow meter. So when we took that flow reading earlier, those dials should be spinning significantly faster than they were when we were looking at the dose. And so what that flow is going to look like is just like the dose when we were talking about. We're opening up 1 and 2, so that's allowing water to go through this disk filter, through the second valve, up and around, through the flow meter, out to the drain field. Now what's going on every time this doses, the pump is pumping more water than the coils can get rid of. So if we look at this picture of a drain field really fast, so let's just call this one down here, this one below the supply line. When the pump kicks on, This tubing can only get rid of water at a certain rate. We talked about those constants, that 0.35 or that zero point 0.7, depending on the size of the coil. The pump is going to be able to pump significantly more water than this tubing can get rid of. So what's going to happen is you're going to have a good amount of excess water that's actually going to fill up this flush line. Even as water is dripping out of these coils, it's going to fill up this flush line and come all the way back into the headworks. And that's why we have, when this valve is closed, this fifth valve is closed, that's why we have pressure on this third gauge. This pressurizes when this flush line fills up with all that excess water. But now when we're doing this part of the startup procedures, we're opening up that fifth valve and giving that excess water a place to go. So that excess water, as indicated by these blue arrows, now with the fifth valve open, allows that pressure to drop, and this water will go down the same way it did when we were flushing the disc filter, back to this vent line and back to the beginning of the system. And so that excess water will move fast enough to actually clean out those coils on a daily basis, and that's what we're looking at there. So this is an idea. Depending on what area you're in, the panels may look a little different in terms of color and where this is located, but you're going to have the same arrangement of toggle switches. And you'll see this toggle switch here located for and labeled as for pump, and then you'll have one toggle switch that controls both valves 1 and 2, because 1 and 2 are always going to work together, so we only have one toggle switch that controls both of those valves. Again, same things with valves 3 and 4, always going to work together, so just one toggle switch for that. And then this outlier, valve 5, a toggle switch for that. Using these, in normal operation, you have all these flipped in the up position so that they're in auto. And then when we're testing and doing this after it's been wired up for our startup procedures, after the installation's been complete and the electrician has come out, we're only going to put things in hand that we want to test, and whenever we're not doing something, we'll have them in the off position. But this is the kind of setup that you'll be looking at, to give you an idea. Just the last couple of notes on the valves specifically. These valves, Netafim valves, will have this blue knob right in the middle. What we're looking at here is, and they should be like this when they arrive, but it's a good thing to check. What we want to make sure is that this blue knob right in the middle of the valve is opened all the way, so turned counterclockwise or to the left all the way. Also, you can see this tiny little tab at the base of the solenoid itself. You'll see one side is colored yellow and one isn't. You want to look down and see yellow. If you see black, flip it over to the side that says yellow. You'll notice also it's really difficult to see, but on this black side, it'll say the word, right on this tab, it'll say the word open. This other side says the word auto, where it's yellow. We want everything in auto, which should be colored yellow. So those are things to look out for. Those being flipped the wrong way, or this little tab sticking straight up and down, vertical instead of horizontal, those will throw off your pressures and valves. And so that's just one thing to look at, making sure that middle knob is all the way opened and that tab is flipped, so when you're looking down at it, you see yellow. But that is it. I want to tell you guys, I'm proud of you. I'm proud of every one of you for going through this thing and watching it. Congratulations, and a sincere thank you from everyone at LOWRIDGE for taking an interest in the Oscar XO2 installation video. If you have any questions, please don't hesitate to call either myself, Jake, or the boss man, Dave, at these phone numbers below. If you're looking to get certified and you just watched this, absolutely call one of us, so that way we can have a little discussion with you and get you on our list of certified professionals. But once again, thank you so much and have a great day. Bye-bye.